section 2.7 talks about the use of absolute value functions and how we can transform them, shift them, rotate them. So this will be just an introduction kind of the what the function looks like. I would assume that you know what an absolute value function is. So you know that an absolute value function has, of course, the absolute value bars. So I want you to think about just a real simple one, the absolute value of x. If I asked you to graph that and you had no idea what it looked like, you could just think about some points and trial and error and hopefully figure out the graph. So for example, if I put 0 and 1 and -1 and maybe 2 and -2, that should be plenty. You'll see what it looks like. If I put 0 in for x, the absolute value of 0 is 0, so y would be 0. If I put 1 in for x, the absolute value of 1 is 1. But if I put -1 in for x, the absolute value of -1 is also 1, hence the y value, both 1. Obviously, same thing going to happen with 2, right? Absolute value of 2 is 2. Absolute value of -2 is also 2, so the output is 2. So if I graph these, I'll just kind of do a sloppy sketch over here. 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. You can see that it's making a V. Now, obviously, the width of this could change. It doesn't have to be centered at 0, 0. It could open down. There are whole lots of things. So that's what we're going to be doing, is we're going to be transforming these graphs. Now, the graph of y equals absolute value of x, we already talked about, is V-shaped. Okay, and it's always symmetric about the y-axis. So for every point xy on the graph, -xy also on the graph. Now, if we shift this, it's not necessarily going to be symmetric about the y-axis anymore. For example, if I take this and shift it over here, it's going to be symmetric about whatever line the x-coordinate of the vertex is on, which probably makes sense. Okay, so this is what we call the parent graph. Y equals the absolute value of x. So it will always make V-shaped, and it's either going to open up or it's going to open down, okay? They never open to the right or to the left, and the shape never changes. Other things that are probably obvious about the graph, the highest or, I'm sorry, this is supposed to be or. The highest or lowest point of the graph is called the vertex, and I'm sure you've heard that word before. That's probably nothing new to you. So in this case, I have a low point, a minimum, which is a vertex. Here I would have a maximum, high point, which is called the vertex. The vertex of this particular graph of the parent function is 0, 0, but again, if I shift this around, it doesn't have to be at the origin. And last but not least, we're going to talk about transforming these finally. So you are, or have been introduced to, the parent function, which is just y equals the absolute value of x. So now we have variables here. We have an a, an h, and a k. So we're going to talk about what those do to affect this parent graph. So I'm just going to remind you down here quickly what that parent graph looks like as best as I can do here. Okay, so that's y equals the absolute value of x. Okay, now you have variables, you have an a, so we'll start with a. Okay, so a is going to tell you if your absolute value function opens up or down. So it's directional for sure. And more specifically, if you have a positive a value, it's going to open up. And if you have a negative a value, it's going to open down. So that's pretty straightforward. However, what a also does is it controls your width. Okay, so as a gets bigger and bigger and bigger, as the absolute value of a, so it really doesn't matter if it's negative or positive 3, as that gets larger and larger, your absolute value function gets narrower. Okay, so as the absolute value of a gets bigger than 1, it's actually going to get narrower. And as the absolute value of a becomes less than 1, your function, your graph actually gets wider. It also works like, and I'm going to put that in quotes, works like slope. So A, don't call it slope, okay? It just works like slope. So for example, if this V has a -3 A value, from the origin, it's going to go down 3 and to the right 1, down 3 to the right 1. So I'd go down 3 to the right 1, down 3 to the right 1. And all these points I would connect. And then of course I do it in the opposite direction to make the V, down 3 to the right, left 1, down 3 to the left 1. And there I would have my absolute value function. Okay, H, and I call it the tricky H. It's a horizontal shift, which that's not tricky, but it's opposite of what you would think. Okay, so note that it's minus H up here. So if H is -5, think about what minus a -5 minus -5 is really +5. So you're going to see an X +5 thinking you need to shift to the right. But H is actually -5, which means you shift to the left. So again, H is a little bit tricky. You always go in the opposite direction. If I can spell here, the opposite direction of what you think. Okay. And then lastly, K, of course, as you can imagine, is your vertical shift. And notice it's plus K, so if it's +5, you move up 5. If it's -7, you go down 7. That's fairly straightforward. Now, I'm not actually going to graph this equation because further videos will go through that, but this is good notes on what all of the variables do for you.